Hello. So, for today, I am going to be discussing about the trapezoidal rule of integration. This video is about how to evaluate the area of an integral. So, um, uh, in this video, ipapakita ko rin kung gaano lang siya ka-simple i-solve and hindi siya ganun kahirap katulad ng iniisip ninyo. So, para hindi na patagalin pa, ay simulan na natin. So, first problem we have is evaluate the area of the integral using trapezoidal rule. So, meron tayong given na function dito, an integral function with a given interval na 5. Okay. So, ang first step na gagawin natin is to write down yung formula. So, take note, wala tayong specific na formula sa pagsosolve ng ating integral using trapezoidal rule kasi nakadepende siya dito sa ating interval or sa n natin kung ilang number of terms magkakaroon sa ating equation. So now, isulat natin ang ating basic formula kasi ano lang naman siya. Although sinabi ko man na magkakaiba is may similarities pa rin sila kasi nagkaiba lang naman sila doon sa number of terms nila. So h over 2 times f x of x0 plus 2 times f x sub 1 plus 2f x sub 2 plus 2f x sub 3 plus 2f f of x sub 4 plus f x sub 5. So, yan. Yan yung gagamitin nating formula para makuha ang area ng integral natin gamit ang trapezoidal rule. Okay. So, kung mapapansin nyo, dito ay ang first term natin is f of x lang. Ganun rin sa ating last term. Ang meron lang dapat na 2 is yung nasa gitna nila ng mga terms. Okay, so now, paano nga ba natin makukuha ang values ng ating f of x's dito? So, we know na given na itong first term natin and ating last term dahil may kita natin ito dito sa ating lower limit and upper limit which is 3 and 4. So, yun ang maging values ng ating f x of 0 and f x of 5. So, una, ang gagawin natin is kukunin natin ang value ng ating h. So, to get the value of our h, we'll use this formula. H equals b minus a over n. So, always, ang ating a is yung lower limit and upper limit naman yung b. So, 4 minus 3 over 5 or yung ating n equals to 1 over 5. Yan ang ating h. Okay. So, next naman is na gagawin natin is to substitute this h into this h over 2. So, ang mangyayari lang dito is ang ating denominator is mamumultiply sa 2. So, magiging 1 over 10 na siya. Now, balik tayo dito sa ating f of x's. Sinabi natin kanina na yung first term natin is always the lower limit or yung ating a. So, ang magiging value ng f of x sub 0 natin is f of 3. Next naman is 2 times f. And ang magiging value ng x sub 1 natin is 3 plus yung ating h na 1 over 5. So, 3 plus 1 over 5 is 16 over 5. So, ganun rin sa ating following terms. Ang gagawin natin is to add the 1 over 5 to 16 over 5. So, bale parang succeeding lang siya. So, 1 over 5 plus 16 over 5 is 17 over 5. Plus 2f, 1 over 5 plus 17 over 5 is 18 over 5. Plus 2f, 1 over 5 plus 18 over 5 is 19 over 5. And ang ating last term, f of x sub 5, is yung ating lower limit, which is yung 4. So, we will put f of 4 for the last term. Now, ang ating last naman, or ang ating next na gagawin is to substitute the values into our equation. So, ang equation natin, 2u squared plus 5. So, ang 3 natin is ang ating u. So, isa-substitute natin ang 3 into u para makuha natin ang value niya. So, substituting this number into this equation, ay makakuha tayo ng answer na 23. Dito naman sa kabila, syempre hindi yan mawala ang 2 times kung anong value ang makukuha natin sa pag-substitute ng 16 over 5 dito sa ating equation. Okay, so substituting this value into this, ay meron tayong 637 over 25. Next naman, 17 over 5. Substitute natin dito. Makakuha tayo ng value na 703 over 25. Plus 2 times, substituting this value, 773 over 25. Okay. For our fourth term, meron tayong 2 times 19 over 5. Substituting here, we will have a value of 847 over 25 plus yung ating last term, which is yung value natin na 4. Substituting here is makakuha tayo ng value na 37. So now, all that's left to do is to add all this up. Pero wag natin kakalimutan na i-multiply sa 2 ang merong 2 sa unahan nila. Okay, so after adding all of these numbers, ay meron tayong value na 1,484 over 5. So, ang gagawin na lang natin is to multiply 1 over 10 into 1,484 all over 5. And we will have a value of 29.68. So now, na-solve na natin ang area ng ating given integral. Now, next naman, meron ba tayong isang example? Using 3 intervals, determine the area of the given integral by using trapezoidal rule. So yan, meron tayong given equation dito. The integral of 2x ln x dx with lower and upper limit 1 and 2, and given na 3 intervals daw dito sa ating equation. So, same lang rin doon sa ating naunang ginawa. Start tayo dito sa pag-write down ng ating formula. H over 2 times f of x sub 0 plus 2f of x sub 1 plus 2f of x sub 2 plus f of x sub 3. Now, yung dito naman, mas maigli siya, hanggang 3 lang siya kasi nga, katulad ng sinabi ko kanina, na kung hanggang ilan ang n natin, hanggang doon lang dapat yung ating x sub 3. So, kung 5 ito, kung 6 ito, dapat doon siya mag-end. Kung n equals 7, hanggang x sub 7 tayo dapat. Pero always tayo mag-start sa 0. Now, next naman natin gagawin is to find yung ating h. So, formula ng ating h, b minus a over n equals ang ating upper limit minus lower limit, 2 minus 1 all over yung ating n, 3. So, we have a value of 1/3 or 1 over 3 na h natin. So, next is we will multiply the denominator to the denominator of this formula. So, magiging 1 over 6 na siya. Now, ang next naman is getting the value for our f ng ating function. So, una, kagaya nga ng sinabi ko kanina, ang ating magiging value dito sa ating first term is always yung ating a or yung ating lower limit. So, since ang ating lower limit is 1, our value here will be 1 plus 2f times, so h or 1/3 plus 1 is equal to 4 over 3 plus 2f 1/3 plus 4 over 3 is 5 over 3. And for the last term, we have the upper limit or our b, which is 2. Okay, next naman is substitute na natin ang ating function dito sa ating equation. So, ang gagawin natin is substitute itong 1 dito sa ating x. So, 2 times 1 times ln of 1. And ang value niyan is 0. Plus, substitute natin itong 4 over 3. Ay makakuha tayo ng value na 2 times 4 over 3 is 1.5343. Next naman is meron tayong 5 over 3, 3.4055. And for the last term, 2, substituting it into our equation, we will get a value of 2.7726. Now, ang gagawin natin is to input this into our calculators. Oh, sorry. Na ano ko na pala siya. na-multiply ko na siya ng 2. Kaya ang value natin dito is already 1.5340 and 3.4055. So, wag natin kakalimutan na laging i-multiply natin 2 sa makukuha ating value dito sa ating equation. So, now, adding all of these values, we will get 7.7124. Now, ang last part na is to multiply 1 over 6 to 7.7124 to get the area na hinahanap sa ating problem. So, we have 1.2854. Okay, so now meron na tayong dalawang problem or practice problem sa ating trapezoidal rule. So next naman, ba tayong last example here para mas maintindihan na kung paano nga ito kinukuha. Kasi sa totoo lang ay napakali lang talaga. So for problem number 3, evaluate the area of the integral using trapezoidal rule with 3 intervals of equal length between 0 to pi. So now, meron naman tayong integral with lower limit 0 and upper limit pi 2 cosine x plus 2 sine x dx. So, kung ganito ang ating equation, same pa rin ang ating gagawin. Start tayo lagi sa paglagay ng ating formula. So, f x sub 0 plus 2 times f of x sub 1 plus 2f of x sub 2 plus f of x sub 3. Since ating n is 3, so last term natin will end with x sub 3. Now, ang next step is to find our h with this formula. Upper limit is pi, lower limit is 0, n is 3, so we have an h of pi over 3. Multiplying pi over 3 into the denominator, 2, we'll have pi over 6. Next is getting the value of our x sub 0, which is already 0 since this is the first term. The first term is always the value of our lower limit or a plus 2 times f. And ang naging value nandito is 0 plus pi over 3, which is also pi over 3 plus 2f pi over 3 plus pi over 3 is 2/3 pi or 2 pi over 3 plus ang ating last term f of pi. Kasi galing siya ating upper limit or ang ating b. Okay, next na gagawin, substitute value here. And wag na yung kakalimutan na pag in calculator nitong values na ito, and we know na ang ating equation is cosine or sine or trigonometry is naka-add ang ating calculator. So, kung substitute natin ang 0 dito sa ating equation, ang mga ating value is 2 plus 2 times pi over 3. Dapat karad tayo sa pag-calculate nito. Value natin is 1 plus square root of 3 plus 2. Ito naman, 3 is negative 1 plus square root of 3. And for the last term, ang ating value na makukuha sa substitute nito is negative 2. So now, meron na tayong values for every f, and all that's left to do is to add all these numbers up and then pi over 6. So pi over 6 times adding all these up, we will get 4 square 3, and then multiplying this value in this value, we will get 3.6276. Now, we have answered all three of the trapezoidal uh, or integral functions or equations using the trapezoidal rule. So kung titignan nyo, hindi na siya ganun hirap solve. Basta alam natin kung paano susundan ang ating process kasi actually madali talaga siya, napakaili lang. And kaya i-solve in less than 5 minutes. Very na yung ng ating integral with use of
Good day, everyone. So we're going to solve a problem involving ODEs, which is we're going to use a shooting method. So in this method, it is a trial and error method where we are going to assume initial values so that hoping that we are going to find the exact solution of a certain ODEs. So we keep trying on some assuming initial values so that we get closer to the exact solution of the ODEs. It is like shooting a crossbow. So from the word itself, shooting, it is like a shooting a crossbow on to hit a certain target, and uh, a number of trials is uh, is needed to hit the exact target. So our problem here in shooting method, use the shooting method to approximate the solution of the boundary value problem. What would be the initial value of y prime of 0 that will yield the solution y of 9 closer to 0? So we are given the ODE, which is d squared y over dx squared is equals to 8x, the quantity of 9 minus x plus 2y, which is given the boundary y, prime, y of 0 is equals to 0, y of 9 is equals to 0. And then what we are asked here is to find the value of what would be the solution that would yield value of y at this point, which is x equals to 9, using this boundary from x equals to 0 and up to the x equals to 9. Would it be A, negative 15.4, B, 12.34, and C, negative 20.57? So in this method, we are going to use also Euler's method because of its simple formula, using a step size of h equals to 3. So meaning using a step size of h equals to 3, at the first step, it will bring us to the at this point, which is x equals to 3. And the second step will bring us at this point, which is x equals to 6. And last step will bring us to x equals to 9, which at this point we are now able to find the value of y equals to 0. So again, this is the equation given, the ODE. So as you can see, the given ODE is in the second order ODE, and recall that Euler's method is only used for first order ODE. So in order for us to solve this problem, we have to reduce this equation into first order ODE. So first, that is, we are going to introduce another variable, which is z, and z is equals to dy over dx. So this equation, substitute natin siya dito. Uh, that will give us dz all over dx is equals to 8x 9 minus x plus 2y. So now that we have this two equation is what we are going to use for solving this problem. We have now two first order ODEs. So at the first equation, it will give us a function 1, which is the function of x, y, z is equals to z. And the equation 2 will give us the function 2, which is the function of x, y, z is equals to 8x 9 minus x plus 2y. But as you can see, as we introduce the variable z, we also need to introduce or assume initial value for this variable. So as I've said lately, we have to assume initial values, and that is uh, dy over dx equals to z is equals to y prime of 0 equals to 4. So this assumption, let's say this is our first trial or our first shot to hit a certain or an exact solution of an ODE. So let's call it our first shot, z equals to 0. So proceeding to the solution of Euler's method, we have the formula yi plus 1 equals to yi plus f function 1 of xi, yi, zi multiplied by h, which is our step size. The same formula applies on finding the value of zi. So first, let's have our I is equals to 0. So here I is equals to 0, 0 plus 1, 0 plus 1. We get y1, so y of 0 plus function 1 of x of 0 is 1, y of 0 is 1 is z of 0 multiplied by h. So the same applies here at the value of z. So now that we already finalize our formula, we have to find our initial values. So that initial values are at this point, which is x equals to 0. So x equals to 0 at this point, y equals to 0. And our first assumption of initial value for z, which is z equals to 4, and our h is equals to 3. So substituting our initial values for solving for y1, we have y of 0 equals to 0, and x of 0 equals to 0, y of 0 equals to 0, and z of 0 equals to 4 multiplied by the h, which is 3. And this is the function 1. Recall our formula for function 1, which is function of x, y, z is just equals to z. So in this given, we will just consider is this one the z. This one. So that is 4. So that is 0 plus 4 times 3 is 12. So that is the value of y1 at x1 equals to x of plus h, which is equals to 3. So let's cut it in the graph. So that is the value of y1 at this point, x plus 3. So next is solving for z1, the value of z1. So again, substituting the initial values. Z of 0 here will become 4. The same apply at this point. And recall our formula for our function 2. That is a function of x, y, z is equals to 8x 9 minus x quantity plus 2y. and substituting these values to the formula. We have 4 plus 8 times x, which is 0, 9 minus x, which is 0, plus 2y, which is 0. That's multiplied by 3, and we will get 4. That is also at point x equals to 3. So, so next is I is equals to 1. So if we are going to go back, so after we solve x equals to 3, we are now solving for y at this point, which is x is equals to 6, this point. So what we are going to use here is the initial values that we obtained at this point. So that is x1 equals to 3, y1 equals to 12, z1 equals to 4, h equals to 3. So these are the values that we obtained lately in our calculations. So substituting again these values, we have 12 plus f1, x is 3, y is 12, and z is 4, and 3, multiplied by 3. So our function 1 dito, we only consider z, which is 4. So that will give us 12 plus 4 times 3, which is equals to 24, and that is at the point of x equals to 6. So solving for z2, that is for substituting the values. This one, substituting the values, we have this 4 plus f, function 2 of 3, 12, 4 times 3. So it will give us 4 plus the formula 8 times 3, which is 8 times x, which is 3, 9 minus x, which is 3, plus 2 times y, which is 12, multiplied by 3. So we get 508, that is at the point of x equals to 6 also. So using that initial values again, what we obtain, we are going to substitute it again to solve for y3. Substitute these values 24 plus a function of 1, 6, 24, 508 multiplied by 3. So we get 24 plus 508 times 3, since we are only considering here is the z, which is 508. We get 1,548, and lastly that is at this point na, which is x equals to 9. And as you can see, we already obtained the value of y here at x equals to 9, and that this is our first shot. So our first shot results to y equals to 1,548, which is far from the exact point where we are going to hit, which is y must be closer or equal to 0. So since our first shot is far from the exact target, it is far from the exact target. So what we are going to do now is to take another trial, or take another shot. So we are going to introduce another assumption for the value of z, or the value of y prime equals to 0, and see what will it give, or what will be the value of y9 at this point. So another assumption. So this since as I said, this is a trial and error. So another assumption will be done in this process. So if we introduce another value, since we already know the the value that is greater than 0, now let's assume a value that is less than 0, which is negative. So let's say negative 24. So if you repeat the steps of Euler's method using H3, you will obtain these values. So calculating that using the discussed method of Euler's, you will get y3 equals to y9, which is this one, negative 216. So now again we solve for the value of y at this point, which is negative 216, which is still far from the exact target, which is y must be equal to 0. So now we can take another shot, but it will take us plenty of time. And since we already obtained two values on the upper and lower of no, we already obtained values greater than and less than 0. I can use the technique of interpolation. So here plotted of our obtained values. In the y prime of 0, 4, we obtain 1548, the value of y9, and on our second assumption, negative 24, we obtain the value of y9, which is negative 216. So what we are going to do here is use interpolation techniques to find out the value of y prime of 0, to find out what will be the value of y prime of 0 that could lead us, that could produce the value of y9 is equals to 0. This one. What will be the value of this one that could produce y9 is equals to 0? This one. So using the equation for a straight line is a equals to a1 plus a2 minus a1 all over b2 minus b1, b minus b1. So we assume uh, we assigned this a1 for our values. So substituting the assigned values, we have a1 plus the 4, a2 negative 24, then a1 again minus 4, b2 negative 216, negative minus 1548, which is our b1, and so on and so forth. Substitute, then solving this equation, we get negative 20.57. So now we solve for, using the interpolation, we solve for another shot. Let's say, let's call it our another shot, but this time this shot is guaranteed that it is closer to the value of y9, which is equals to 0. It might be equal or closer to y equals to 0 because it is just an approximation. So if we are going to repeat the steps of Euler's method using h equals to 3 and using this initial value, negative 20.57, we will get these values. We will calculate these values, which is at the last step, which is I equals to 3, we will obtain 0.09. So that is now closer to the exact target, which is y must be equal to 0. And we are now closer to that exact target. So the initial value that we get, or let's say our best shot will be, our best shot to find the exact solution at this point will be y prime of 0 equals to negative 20.57. So since it is our best shot, it is the answer in the multiple choice. And that would be all for this presentation. Thank you.
Now we're going to answer the questions in shooting method. Question number 1. d2y over dx squared minus 2y equal to 8x open parenthesis 9 minus x close parenthesis, with y of 0 is equal to 0 and y of 9 is equal to 0. We can assume that our y prime of 0 is equal to 4 and y of 0 is equal to 0. d2y over dx squared is equal to f times x y dy dx. d2y over dx squared is equal to 2y plus 8x open parenthesis 9 minus x. Now we're going to find our equation. dy over dx is equal to z. This is our equation 1. equals to f1 x, y, z, y of 0 is equal to 0. dz over dx is equal to 2y plus 8 times 8x open parenthesis 9 minus x close parenthesis. This is our equation 2. For using equation 1, yi plus 1 is equal to y1 plus f1 times xi yi zi times h, and therefore equation 2, zi plus 1 is equal to z1 plus f2 times xi yi zi times h. Now let's proceed to find to get the y1. I is equal to 0. y1 is equal to y of 0 plus f1 times x of 0, y of 0, z of 0 times h. Z of 1 is equal to z of 0 plus f2 times z of 0, y of 0, z of 0 times h. Z of 0 is equals to y of 0 equals 0 times z of 0 equals 4, and our h is 3. This one. y1 is equal to 0 plus f1 times 0, 0, 4 times 3. 0 plus 4 times 3 equals 12. Our y1 is 12. Now z1. z1 is equal to 4 plus f2 times 0, 0, 4 times 3. 4 plus 2 times 0 plus 8 x times 0 open parenthesis 9 minus 0 close parenthesis times 3. 4 times 0 times 3 is equals 4. z1 is 4. Y of x1 is equals to y1 equal to 12. Z of x1 is equals to 4. Our x1 is equal to 3. Now let's proceed to I is equals to 1. y2 is equals to y1 plus f1 times x1 y1 z1 times h. z2 is equal to z1 plus f2 times x1 y1 z1 times x1 is equal to x0 plus h is equal to 0 plus 3 equals 3. Our y1 is equal to 12 and our z1 is equals to 4. z2 is equals to 12 plus f1 times 3, 12, 4 times 3 is equal to 12 plus 4 times 3 is 24. z2 is equal to 4 plus f2 times 3, 12 and 4 multiply by 3 is equals to 4 plus 2 times 12 plus 8 times 3 times 3 times 9 minus 3 times 3 is equal to 4 plus 168 times 3 is equal to 508. Y of x2 is equals to 24 and z of x2 is equals to 508, and our x2 is equals to 6. Now let's put I equals to I is equals to 2. y3 is equal to y2 plus f1 times x2 y2 z2 times h. z3 is equal to z2 plus f2 times x2 y2 z2 times h. x2 is equal to x1 plus h is equals to 3 plus 3 equals 6. y2 is equals to 24. z2 is equals to 508, and y3 is equals to 24 plus f1 times 6. 24 508 times 3 is equals to 24 plus 508 times 3 is equals to 1548, and our x3 is equals to y3 is equals to 1548. Y prime 0 is equals to 4, and y9 is equals to 1548. This one are not equal. This not equal. Now we need to choose again for another to get the equal. So I choose negative 24, like what I did in first we choose using the step of Eutric method. For getting I0, I1, I2, I3, we can get the x1 of 0, 3, 6, 9, and our yi is 0, negative 22, negative 144, negative 216, and our z1 is negative 24, negative 24, negative 24. This is when we choose negative 24, and our y3 is equal to negative 216, also is not equal to y9. Now let's proceed using this formula. By using the answer we get earlier, we can get the negative 20.57 by using this PO plus P1 minus PO over Q1 minus QO multiplied by Q minus QO. P is equal to 4 plus negative 24, negative 4 over negative 216 minus 1584 times 9 minus 1548. This will cancel, becomes 0, and we can get negative 20.57. Now we will choose again, as our y prime of 0 is this 20 minus 57. By using Euler method, we can get our I of I0, I of 1, our x1 is xi is 3, and our y is negative 61.7, and z is negative 20.57, and 2 I2 xi is 6, and y is negative 123.43, and the z is 41.17, and I3 is x is 9, and y is 0.09. By using 0.59, that we can get the equal 0.09 to y of 9. This is the final answer. Number 2. d2y over dx squared minus 2y is equal to 0, with y of 0 is equal to 1.2 and y of 1 is equal to 0.9 and our h is equal to 0.25. Can simplify this. I derive this as f of xy dy dx dy dx is equal to z is equation 1 f1 times xyz, and dz over dx equals 2y f2 times xyz. We can guess negative 2. We can assume that negative 2 dy dx is equals to negative 2 equals z. Now let's proceed to first integration. x1 is equal to 0.25, and our y1 is equal to y of 0 plus h plus 1 times x of 0 plus y of 0 plus z of 0 is equal to 1.2 plus 0.25 f1 times 0, 1.2 and negative 2 is equals to 1.2 plus 0.25 times 0.2 is equals to 0.7. Our x1 is y1 is 0.7. z1 is equal to z of 0 plus h f2 times x of 0, y of 0 and z of 0 is equals to negative 2 plus 0.25 f2 times 0, 1.2 and negative 2 is equals to negative 2 plus 0.25 times 2 times 1.2 is equals to negative 1.4. Now let's proceed to second. For the second, x2 is equals to 0.5, y2 is equals to y1 plus h plus hf times x1, y1 and z1 equals to 0.7 plus 0.25 plus 0.25 times 0.7 minus a negative 1.4 equals to 0.7 plus 0.25 times negative 1.14 is equals to 0.35. y2 is 0.35. Let's proceed to third. y3 is equals to 0.75. y3 is equals to 0.35 plus 0.25 f1 times 0.5, 0.35 and negative 1.05 is equals to 0.35 plus 0.25 times negative 1.05 is equals to 0.0875. Or z3 is equals to negative 1.05 plus 0.25 f2 times 0.5, 0.35 negative 1.05 is equals to negative 1.05 plus 2.25 times 2 times 0.35 is equals to negative 8.75. I forgot the second, z2 is equals to z1 plus h f2 times x1, y1, z1 is equals to negative 1.4 plus 0.25 f2 times 0.25, 0.7 and negative 1.4. Negative 1.4 plus 0.25 times 2 times 0.7 is equals to negative 1.05. 1.05 is our Z2. And we finish already this one. Now let's proceed to the fourth. Our x4 is equals to 1. y4 is equal to 0.0875 plus 0.25 f1 times 0.75, 0.0875 negative 0.875 is equal to 0.0875 plus 0.25 times negative 0.875 is equal to negative 0.1313. This is our y4. Our z4 is equal to negative 0.875 plus 0.25 f2 multiplied by 0.75, 0.0875 minus negative 0.875 is equals to negative 0.875 plus 0.25 times 2 times 0.0875 is equals to negative 0.8313. Our x4 is 1, y4 is negative 0.1313, z4 is negative 0.8313, y4 of 1 is equal to 0.1313 is not equal to 0.9. Because of that, we can go to our second guess, or we can assume again another number. Now we assume it negative 1. dy over dx is equals to negative 1 equals z. By using the first to fourth iteration of I0 to I4, I0 has x is equals to 0 and y is equals to 1.2 and z is negative 1, and I1 is 0.25 and y is 0.95 and z is negative 0.4, and I2 is x is 0.5, y is 0.85, z is negative 0.075, and for I3 0.75 and our y is 0.8688 and the z is 0.5. For I4, our x is 1, our y is 0.9938, x4 is equals to 1 and y4 is equal to 0.9938, also not equal to 0.9. Like in the other question from the question number 1, we can also use this formula to get the third guess, to get the final answer, to get the equal. Z is equal to G1 plus G2 minus G1 over R2 minus R times D minus R1. RD is 0.9. RG is, we can use G or whatever, is equals negative 2 plus negative 1 minus negative 2 over 0.9938 minus 0.1313 times 0.9 minus negative 0.1313 is equals to negative 1.0834. Using this negative 10834. With our third guess, we can get the I 0 1.2 and Z is negative 1.0834, and for 1 is 0.25, 0.9292, negative 0.4834. 2 and I2 is 0.5, 0.8084, negative 0.0188, and for our I3 0.75, 0.8033, 0.3854, and for I4 our X is 1 and our Y1 is 0.8997. Y4 of 1 is equal to Y of 1 is equals to 0.8997 is equal to 9.0. When we round off that, it will be equal to 9.0. This is our answer. That's all.
Now let's proceed to our third question. Partial differential equation of a temperature in a long thin rod is given by this formula. So if we compare our third problem into our first problem, so the temperature of at node 0 in our first problem, it was already given, but here it was insulated. So let us continue and see what will happen if our temperature at node 0 was insulated. So if A is equals to 10 centimeters square centimeter and per seconds, the initial temperature of rod is 20 Celsius and the rod is divided into 3 segments. The temperature at node 1 using delta T is 0.3 seconds by using an explicit solution. So T is equals to 0.6 seconds for node 0. So let us also familiarize for our formula, where K is 10 and then our H is equals to 20 and our final temperature is 25 and our initial temperature is 0. So before I tell you the correct answer, let us proceed to our solution. So here's the given, and then now let's compute or solve the number of division of the rod or the segment. So let us define the value of delta x, which is the formula is L over N. So the value of our length is 15 over the number of our rod is 3. So we will get 5 centimeter. And now let's proceed to our next, and the number of time steps. So the formula is final time minus the initial time over the delta time. So our final time is 0.6 and our initial time is 0, and then our delta t is 0.3. So we will get the answer 2. And then our next formula is lambda is equals to our A is equals to delta t and over delta x squared. So let's input the values and we will get 0.12. So let's check 0.3 over, so 0.12. Then the boundary conditions. So here our temperature at node temperature 3 at node 1 is equals to 25 centimeter, and then approximating the derivative by the central divided difference. So in our formula, so let us rewrite. So this will be the result. We rewrite our formula from here, and then the next that we will do is to substitute all the equation, and then we will get this equation. Then next we will proceed to our solving, and the initial temperature of the rod is 20 Celsius. So the temperature of the nodes inside the rod are already 20 Celsius, and then when time is 0, so accept the boundary nodes as given. So the equation will be or the result of our temperature is, for our temperature 0 at node 0 is 20, since we already discussed that all the temperature inside the rod are 20 Celsius, except the temperature 3 at node 0, because it was 25 Celsius. So next, the temperature at the nodes inside the rod when time is 0.3 seconds, setting our values, or here as a values. Now for our temperature 0 at node 1, let's input our value in our equation. So the value of our temperature at node 0 is 20, and our copy into, and then our lambda is 0.12, and then our temperature 1 at node 0 is 20, our temperature 0 at node 0 here, so 20, and then the value of our h is 20, and the value of our k is 10, and then our delta x that we get before is 5 cm. So, and then 25 for our final temperature, and temperature 0 at node 0 is 20. So let's input in our calculator, and we will get 32. And then for our temperature 1 at node 1, so let's also input our values in our equation, which is temperature 1 at node 0 plus lambda, and close open parenthesis by times temperature 2 at node 0 minus 2 times temperature 1 at node 0 plus temperature 0 at node 0. So we will get the answer of 20 Celsius. And also the same for our temperature 2. We need to input our values, and we will get 20.6 Celsius. While our temperature 3 is 20 Celsius. Now, temperature at nodes inside the rod when T is 0.6. So now we will determine what will happen if our time is 0.6. So our T0 at node 2 is equals to temperature 0 at node 1. So it is 32, and then our lambda is 0.12 multiplied by temperature 1 at node 1. So temperature 1 at node 1 is 20, and then temperature 0 at node 1 is 32, and the value of our HK is 20 over 10. Delta X is 5. Our final temperature is 25. Our temperature 0 at node 1 is 32. So we will get the answer of 12.36. And then for our final answer, we need to find the temperature 1 at node 2, which is the formula is almost the same to the previous equation, but the values is not. So temperature 1 is temperature 1 at node 1, so 20. Our lambda is 0.12, and our temperature 2 at node 1 is 20.6. So we'll use the temperature that we get for this. And then 2 times temperature 1 at node 1. So our temperature 1 at node 1 is 20. So, and plus temperature 0 at node 1, which is 32. So let us input in our calculator, and we will get the final answer is 21.512. So the correct answer is letter A. So this is the correct answer. So that's all. Thank you so much. Hey guys, again, this is the continuation of our discussion about the solution of questions under the topic of parabolic partial differential equation. So here's the question: the region in which the following partial differential equation. So here's the given problem, and x as a parabolic equation is, so we need to solve this equation to get the correct answer. So now let's proceed to our solution. So a general partial differential equation with two independent variables is of that form. So we need to organize first at in standard form. So we need to determine our values of our a, b, and c. So where a, b, and c are functions of x and y, and is a function of x, y. So for this equation to be parabolic, b squared and 4ac is our formula. So the values of our a, b, c, so we need to determine. So the value of our a is x cubed here, and for our value of our b is, which is here, 5, and value of our c is 25. So now let's input the values of a, b, c into our formula. So b squared is here 5, and for our a is x cubed, and for our c is 25. So 4 times 25 is 100x cubed. So we need to copy na lang, and then 5 times square of 5 square is equals to 25, and then we need to divide to 100 to cancel out, and then we will get the x cubed and 1/4, and then we need to the x is only we need to get, that's why the 3 we will move here, and then we will get the answer of 1/4 raised to 1/3. So the correct answer in this question is letter C, which is here. So this is the correct answer. So thank you so much, guys. So in this video I will be discussing the solution of the multiple choice problem under the topic of parabolic partial differential equation. So here's the first question. The partial differential equation of the temperature in a long thin rod is given by this equation. So at node 0, our temperature is 70 Celsius, while in our node 3, our temperature is 15 Celsius. So our length is 10 centimeters. So if A is equals to 0.5 cubic centimeter per second, the initial temperature of rod is 40 Celsius, and the rod is divided into 3 equal segments. The temperature at node 1 using delta T 0.2 seconds by using an explicit solution at 0.2 0.4 seconds. So the correct answer here is letter B. So now let's proceed to our solution to show you how to get this answer. So let us first determine the number of division of the rod, which is 3. So delta x is equals to L over N. So let us input our values and we will get the answer of 3.33333. Next, the number of time steps. So our formula is final time minus the initial time over delta time. So let us input the value. Our final time is 0.4 and our initial time is 0, while our delta t is 0.2. So we will get the answer of 2. 0.4 minus 0 over 0.2. So we'll get the answer 2. And then for our next formula, so delta of equals a multiplied by delta t over delta x squared. So let's input the values and we will get the value answer of 0.009. And now let's proceed to our next. The boundary conditions. Our temperature at node 0 is 70 and our temperature at node 3 is 15, while our temperature at node 1 is 15 Celsius. So now the initial temperature at nodes inside the rod when T is 0, so temperature at node 0 is 70 and the temperature at node 1 is 40, while the temperature at node 2 is 40 and the temperature at node 3 is 15. So temperature at nodes inside the rod when T is 0.2 seconds, so this is well done. So our temperature at node 0 is equals to 70, and for our temperature 1 at node 1 is the formula is our temperature at node 1 so is 40, and the value of our lambda is we already get before is 0.009, and the value of our T2 is 40 and minus and then minus 2 and then multiplied into our temperature at node 1, which is 40. Then our temperature at node 0 is 70. So we will get the answer of 40.27 Celsius. So next, into our temperature at node 2, which is the formula is T at node 2 is 40 plus our lambda is 0.009 and then multiply by the value of our temperature at node 3, which is 15. So and then minus 2 and then multiplied into our temperature at node 2, which is 40, and then plus temperature at node 1, which is 40. So we will get the answer of negative 25. So I already put. So and then we need to multiply by 0.009 plus 40. So we will get the answer of 39.775 for our temperature at node 2. And then our temperature at node 3 is still the same, 15 Celsius. Next, temperature at nodes inside the rod when T temperature is 0.4 seconds. So this will happen. So for our temperature at node 1, if our time is 0.4 seconds, so temperature 1 is 40, and our lambda is still the same, 0.009. And then our temperature at node 2 is 39.775 here. And then our temperature 2, temperature 1 is 40.27. We need to multiply them by 2, and then we need to plus the temperature at node 0, which is 70. So let's input in our calculator, and we will get the answer of 40.5331. So the correct answer is letter B. So that's all for our first question.